Good afternoon, sir. I'm Cadet Daminar. Our bridge is called America's Bridge. Our group was tasked with finding a cost-effective bridge for the town of Trussville that is safe and efficient. Our team consists of Cadet Shaw, Cadet Hefner, and Cadet Daminar.
I'm Cadet Hefner, and I'm going to be going over our decision matrix and how we made the decision to pick our truss. So the first, we evaluated upon 3 criteria. The first one being the most unique looking. The town of Trussville wanted a unique truss for their bridge, and we're here to provide that for them. We then went on the most cost effective based off the amount of material that we would need to use. And then the final was the highest factor of safety, because we want to provide them the safest bridge we possibly can. So using these 3 criteria, our first truss scored, the final truss we went with scored an 85. This was the highest uniqueness score compared to an 80 and a 70 for our alternate truss. This had a weight of 1 out of a score of 100. Then for the amount of material used, the way we determined this was we took the inches used per side of the truss, put that over 100, then subtracted that by 1, multiplied it by 100, and then that was weighed at a 1.25 weight. So for that, our alternate truss 1 actually came in with the best score at 124.95 after being weighted. And then for the highest factor of safety, this is when our main truss really was able to take the cake and end up being the one we go with, because it had the highest factor of safety with a weight of 1.5 out of a score of 100, with the factor of safety of 3 being 100 points total. This bridge was constructed with a factor of safety of 2.
For the design of our bridge, we found the forces of each member, and by doing this, we found that the 2 members that are likely to break are members CF and CG. This is because they're the longest members and they have the most amount of force and compression on them. We believe that it will have a positive shear force that will create buckling and destroy these 2 members first if the weight exceeds the factor of safety limit on it. Next, looking at ethical concerns, we used mostly 1/4 inches instead of 1/8 inches because we wanted to increase our factor of safety even more, and this increases the structural integrity. Now, into environmental thoughts, we took the wasted resources from our cuts and we added them back into the bridge to create added structural integrity, as you can see here, and on the top. Overall, our bridge design takes into account a large factor of safety, ethical concerns, and environmental concerns, and this will create a safe bridge for the town of Trussville.